Hello students, with the chapter triangles, all of you understand the concept of similarity, and I'm having a triangle as you can see in the figure, and in this triangle there are 36 triangles. Each smaller triangle is similar to the larger one. Now let me tell you one thing. If I consider as all the smaller triangles are of equal areas, all are congruent, smaller triangles are congruent to each other. So I consider the area of each smaller triangle is 1 unit. Now, if I consider triangle, I am naming it A, B, C. Now you can see that in triangle ABC there are 4 triangles. So what is the area of triangle ABC? It is equal to 4 square units. So I can write down area of ABC, area of triangle ABC is equal to 4 square units. Now if I take this smaller triangle, as you can see, this smaller triangle, so it is similar to the larger one. And what is its area? Its area is, I am naming it PQ. So area of triangle PBQ is equal to 1 unit square. Now we can clearly observe here that area of triangle ABC upon area of triangle PBQ, so it is equal to 4:1. Now if I observe here that what is the ratio of their sides, as we can observe, the side of AB is double that of side of PB. So if I write here, it is side, it was, if side of AB is 2A, then side of this is A. So if I square them, I get 4A square upon A square. So it is equal to 4:1, and that what I have obtained. In the same way, if I consider this triangle MBN, in triangle MBN we are having total 9 triangles. So therefore area of MBN is 9 unit square, and that of PBQ is 1 unit square. And what is the ratio of their sides? It is 3:1. So the area of bigger triangle, that is MBN, is 9 unit square, and that of smaller is 1 unit square. If I take the ratio, I will get 9. And I observe that in all these cases, if I am taking two triangles, similar triangles, in that case the ratio of their areas is equal to the ratio of the squares of their corresponding sides. Now I am proving a specific theorem for you. Let us do it. Now here the statement for the theorem is, the ratio of the areas of two similar triangles is equal to the ratio of the squares of any two corresponding sides. Now let us prove it. So what is given here is, we are given that triangle ABC, that is ABC and PQR, both of these are similar triangles. And what do we have to prove? We have to prove that area of triangle ABC is equal to BC square upon QR square, as BC is corresponding to QR, CA is corresponding to RP, so CA square upon RP square is equal to AB square upon PQ square. Now in order to prove this theorem, I need some construction. So draw AM perpendicular to BC and PN perpendicular to RQ. Now in order to prove this theorem, I'm proceeding with it. You know that triangle ABC is similar to triangle PQR. As we know that if two triangles are similar, in that case the ratio of their corresponding sides are equal. So I can write down AB upon PQ is equal to BC upon QR is equal to CA upon RP. Let it be 1. I also know that area of triangle ABC upon area of triangle PQR is equal to, as we know that area of triangle is half into base into altitude, corresponding altitude. So in case of triangle ABC, half, if I take base BC, then corresponding altitude is AM. And in case of PQR, half, if I take QR as base, then corresponding altitude is PN. So half gets cancelled, so I am left with area of triangle ABC upon area of triangle PQR is equal to BC upon QR into AM upon PN. Let it be second. But we had to prove that AB square upon PQ square, BC square upon QR square, that is equal to area ratio of the areas of the triangles. Now I have to get this result. So in order to get this result, what do we do? I take these two triangles. I'm taking triangle this one and this one. I have crossed these. So keeping this in mind, I'm writing in triangle ACM and triangle PRN. You know that angle C is equal to angle R? The reason is that both of the triangles were given to be similar, and as we know that similar triangles have equal angles. After that, angle AMC is equal to angle PNR. Each is equal to 90 degree. That we can write down by construction. And it was due to triangle ABC is similar to triangle PQR. So their corresponding angles are also equal. Now as the two angles of one triangle are equal to the two angles of the other triangle, therefore we can write triangle AMC is similar to triangle PNR. And as these two triangles are similar, therefore the ratio of their corresponding sides is also same. So I would not take this CM or RN. Remaining two sides I can take. So I am taking AM upon PN. So AM upon PN is equal to AC upon PR. AC upon PR. It is number 2. Now, clearly from second, third and first, from all these collectively, I'm having all these here with me. It is first, second and third. If I observe all these three from first, second and third, you know that from second and third, AM upon PN is there also, and we also know that from first, AB upon PQ, BC upon QR. BC upon QR is equal to CA upon RP, and that is in third. So from first, second and third, we can directly write area of triangle ABC upon area of triangle PQR, as I can replace BC upon QR as such, and I can replace AM by PN with BC by QR from first, second and third. So what result do I get? I get area of triangle ABC upon area of triangle PQR is equal to BC square upon QR square is equal to. In the same way, we can prove that similarly area of triangle ABC upon area of triangle PQR, area of triangle ABC upon area of triangle PQR, we can prove CA square upon RP square and AP square upon PQ square, and that is the proof for theorem. And using this theorem we can solve a number of questions easily. Please try to solve questions based on these theorems from your NCERT and any other extra book. Let us meet in the next video.